First things off, we would like to preface that entanglement is a scientific property and that explanations used here are to help better our understanding of it. So, imagine that you have a house. This house is connected to a power grid. When you flip the light switch, you will know if the house has power. In this case, the lights turned on. Now imagine there are two houses. They are connected to the same power grid. So, it is logical to assume that if one house has power, the other one does and vice versa. Now, let's talk about entanglement. Consider two entangled coins that are spinning in the air. What state are the coins in? Heads or tails? Well, they are actually both heads and tails at the same time. What happens when you stop one coin and measure its value? Because of entanglement, we now know the state of both coins instantaneously. But how is entanglement formed, and is it preserved? Think of kids telling secrets. The two kids are whispering and sharing information. This interaction is similar to how their entanglement is formed. Just like entanglement, there is no physical connection in this scenario. Thanks to that fact, the information is still preserved at distance between the kids. Both kids have the same information at the same time, no matter if they are together or separated. Let's go back to our houses and think of them as entangled. Both houses have lights on. Both houses have lights off. Even in completely different parts of the world, entanglement still works, even if the house is in Greenland or Antarctica. If the lights are on in Greenland, then the lights will also be on in the Antarctic. Now imagine we have two houses that are entangled. For these houses, we need to open the door to see if the light is on. We check to see if house number 1 has a light on. Now we know that both houses have lights on. However, the door was an integral part of the house structure, and opening it caused the first house to crumble. Even though the first house collapsed, we still know the property of the second house. This shows one of the properties of entanglement. It gives us a way to understand properties of an entangled element, even if measuring the properties of one is destructive. When we measure information of one particle, we know what is happening with the second particle, no matter where it is, even if our measurement destroys the first particle. Entanglement is important for current quantum technologies to develop. It is also important to note that we are still early in the development process of quantum technologies. There are already clear outlines of possible applications to create new technologies. The most notable of these is quantum computing, which falls under the larger umbrella of quantum information. Other technologies include quantum sensing and quantum clocks. Though these technologies will continue to develop and look nothing like they do today, it is important to understand the foundations on which they were developed from, which quantum entanglement is a great place to start.